Okay, so in this video, I'm going to try and define what a vector really is and what a vector space is. The reason for doing this is that in school physics, one is usually taught that vectors are used to represent quantities which have direction and that they have a magnitude and direction, etc. Right? While this is true, this is a highly restrictive definition of vectors. For example, in quantum physics, vectors can be used to represent probabilities. In relativity, vectors can be used to incorporate the rate of flow of time in a reference frame, etc. So it is really necessary to understand vectors before doing any physics because they form the basic structure of physics. So let's begin trying to understand vectors. So this is the usual way of understanding vectors. That is, if something has a direction, this could be, for example, a force in this direction or a velocity. You can always break it up into two components. One is along x and one is along y. And the x component can be written. So here the x component is 1, so you write it as 1 I cap. And the y component, the component along y direction is 2, so 2 units compared to the x, so you write it as 2 j cap. So and so on and so forth. So a direction like this b can be represented as 3 I cap and 1 j cap. Now let's look at what are the properties of vectors, the general properties of vectors, in if you consider them as directions. So the resultant vector is usually given if you wanted to add a and b. You just add the respective components along x and you add the respective components along y. That gives you a new vector. So to summarize this, whenever you're adding vectors, you need to just add the respective components along the direction, along a particular direction, and you get the final resultant. So this property that when you add two vectors, you get another vector, and that you only need to add the respective components is known as vector addition. This is a particular property of vectors. So when you're adding vectors, you add the respective components and you get another vector. So a plus b gives you another vector. So that property is known as vector addition. And another property known as scalar multiplication is when you take a scalar could be any number, and you try to multiply this vector a with that. So let's say you try to multiply this vector with the number 3. So when you do that, you have to multiply each component with the number 3, and you get 3 times the x component, 3 times the y component. This is known as scalar multiplication. Each component gets multiplied by that number. So if so from what we see here is that vectors follow these two properties, vector addition and scalar multiplication. And if there are other things that sort of follow the same property, we can call them as vectors as well. We'll see soon what they could be. But anyway, also notice that each of these vectors a, b, r or any other vector c can be represented as combinations of I and j. This has got 3 times I plus 6 times j. This has got 4 times I plus 3 times j. So actually speaking, these I and j are vectors themselves. They are more basic vectors. So any given vector can be represented in terms of I and j. So since they are basic vectors, they have another name. They are called as basis vectors. Basis vectors simply means they are those vectors using which you can represent every other vector. And they form the basis set, what is known as the basis set. Collection of all the basis vectors will become the basis set. And so I and j cannot be represented in terms of each other because they are completely independent of each other. But all other vectors can be represented with respect to I and j. So that's something you need to remember about basis vectors. Now moving on, so if I think of A as one as a column vector 1 and 2, and B as another column vector 3 and 1, that's exactly like this. Here it's the first part here is 1 and the 2 j cap here is 2, and similarly B is 3 and this is 1. Now let's see if I add A, I can represent A, the same thing, as a sum of 1 into 1 0 plus 2 into 0 comma 0 1, and if you add them you'll get the same thing. So it seems like I can represent this like this. So you can think of this as the I cap, 1 I cap plus 2 j cap. Similarly, B can be represented as 3 into this 1 0 plus 1 into 0 1. So 3 I cap plus 1 j cap again. When I add A plus B, if you know how to add matrices, you're only going to add this with this and this with this. So what you're finally getting, what you should finally get is 4 plus 4 and 3. So you should be getting 4 and 3, which you will, but when you're adding them you're actually just adding the respective components, that is 1 with 3, 1 plus 3 plus 2 plus 1. So it's exactly like vector addition. So you'll end up getting just 4 3, which is the sum of these two, which was also what we had got here, R as 4 3. So it seems like matrices also behave like vectors, but only particular kinds of matrices. So, and even multiplication, when I try to multiply 3 into A, I'm multiplying each component here. So I can say all matrices, these have 2 rows and 1 column. So all matrices of the order 1 comma 2 or 1 cross 2 form vector space. A vector space simply means that each of the elements is a vector. And what are the basis vectors here? The basic vectors here are 1 0 and 0 1, basis vectors, and these two form the basis set. So yeah, that's it. So even matrices can be thought of as vectors, and they'll be used to represent different things. So this, I hope, gives a general idea of what are vectors. Anything that follows vector addition, adding components, and scalar multiplication are vectors. So in the next video I will try to explain what other things could be vectors. Meanwhile, you can think about what are the other things, other quantities that could also be vectors. Yeah.